In this video, we'll take a look at section 9.1. Chapter 9 starts on talking about vectors and applications of vectors. So 9.1 is an introduction to what a vector is. So two vocabulary words that we're going to start with is a scalar. So a scalar is a quantity described by magnitude only, such as length, area, time, temperature. A vector is a quantity described by both magnitude and direction. So here's an example of the difference between the two. Example 1, a jet is traveling at 600 miles per hour. From this statement alone, we know only the speed of the jet. Speed is a scalar quantity and tells us only the magnitude of the rate. Knowing only the speed of the jet, we know the rate at which it's moving, but we do not know where it's headed. If the phrase "in a direction 10 degrees south of west" is added to the sentence about the jet, we specify the direction of travel as well as the speed. We then know the velocity of the jet, that is, the direction of travel as well as the rate at which it's moving. So velocity is a vector quantity. So that's the difference between speed and velocity. Speed just tells you how fast it's going. Velocity means we know how fast something is going along with the direction. So before we look at an application, we're going to take a look at adding vectors. And this one we're going to take from a geometry perspective. So in geometry, we have actual physical lengths of vectors. So a vector, we represent a vector quantity by a letter printed in boldface type. The same letter in italics, types, and lightface represents the magnitude only. Thus, capital A is a vector of magnitude, bold A is a vector of magnitude, not bold A. In handwriting, one usually places an arrow over the letter to represent a vector, such as A with a little arrow over the top. That represents vector A. If A and B represent vectors directed from O to P and P to Q respectively, so I'm going to use this example. So vector A, if it goes from O to P, and vector B, P to Q, the vector sum A plus B is the vector capital R from the initial point O to the terminal point Q. Here vector capital R is called the resultant. So here's what it looks like. So adding vectors means we take vector A, and if we put that O, P, then vector B we put right up against the end of vector A, P, Q. So we arrange the vectors so that they're right next to each other. And so we have the initial side, the terminal side of A, and then the initial side of B is next to the terminal side of A. Then that diagonal that we draw, or that connector, the third side of the triangle, is the resultant R. So vector A plus vector B is equal to capital R. So physically, that's how you draw the sum of two vectors. So there are two common methods of adding vectors. The first method is called the polygon method, and that's what we just did right here. To add B to A, shift B parallel to itself until its tail touches the head of A. Then the vector sum A plus B is the resultant vector R, which is drawn from the tail of A to the head of B. So in using this method, we can move a vector for addition as long as its magnitude and direction remain unchanged. Because the magnitude and direction specify a vector, two vectors in different locations are considered the same if they have the same magnitude and direction. So if we're using a diagram, which we are in this section, you have to draw them accurately. So we can add more than two vectors. We can add vectors A, B, and C. So we're given a vector A, B, and C. If we add A plus B plus C, we take vector A and draw it. Remember, it's the same direction, same magnitude. Then we take vector B and move it so that the initial side of B starts at the terminal side of A. Then we take vector C and move that over. And the resultant is where we started, initial side of A to the terminal side of C. So the other picture shows you that you can add in different orders. Remember, addition is commutative. We could take A plus C plus B, but if you do A, then C, then B, you still end up with the same resultant vector. So it doesn't matter what order, you'll still end up geometrically with the same answer. All right, so that's the polygon method. There's another method called the parallelogram method. So in this method, instead of taking A and B and putting them terminal side, initial side, if we add vectors A and B, the parallelogram method puts A and B tail to tail. They share the same initial side. And then we draw a parallelogram, sketch in a parallelogram. And then the resultant is the diagonal of the parallelogram. So that's another way to add vectors. So notice this is A, this length right here is B. So that's how it's similar to what we did before. Okay, so we can use a parallelogram method. All right, we can also add together multiples of vectors. So for vectors A and B, if we're going to take 3 times A plus 2 times B, vector A, 3 times A, is a length that the same direction as A, but it's 3 times larger. So it's putting A times 3. So this is the vector 3A. And then the vector 2B is B twice as large. So we're going to take the initial side of 2B and put it next to the terminal side of 3A. And then the resultant vector, this vector, is our answer. Okay. And last, if we're going to subtract vectors, think about it as adding a negative. So if you're given vector A and B and you want to take 2A minus B, it's 2A plus a negative B. So if B is going in this direction, then negative B is the same vector, except it's going in the opposite direction. So it's the same length, opposite direction. So when we take the vector 2A, here's our vector 2A, and then put next to it minus B, instead of B going this direction, it goes the opposite direction. And then our resultant is starts at the initial side of 2A and ends at the terminal side of negative B. So this is the length. So we're drawing vectors. So I want to take a look at just one example. Okay, so there's an important vector quantity, velocity and displacement. So velocity as a vector we're going to illustrate it here. The displacement of an object is its change in its position. Displacement is given by the distance from a reference point and the angle from a reference direction. So we just want to see an example. To avoid a storm, a jet travels 60 degrees north of east from Detroit for 190 miles. So we've got a direction, 60 degrees north of east for 190 miles. So there's our magnitude, 190 miles, and our direction, 60 degrees north of east. And then turns to a direction of 10 degrees north of east. So now it's turning 10 degrees north of east and going to travel another 280 miles to Ottawa. Find the displacement of Ottawa from Detroit. So displacement is this green. It's adding the two vectors together, and displacement is the green. So if you make a scale drawing and then measure, then measuring a distances with rulers and angles, we find that Ottawa is about 420 miles from Detroit, so that resultant vector is 420 miles, and an angle of about 30 degrees north of east. So we'll take a look at this using trigonometry later. I just wanted an example so you can see where the drawings are used. So by giving both magnitude and direction, we've given the displacement.